Okay, let's talk about a very powerful dependency breaking technique that you can apply in your legacy code. This technique is called extract and override, and has been introduced by Michael Feder in a famous book, Working Effectively with Legacy Code. So here I have a class called plugin service with a method count plugins that count the number of plugins that satisfy a particular filter that I provide. And the count plugins method itself is also kind of creating the account configuration and getting the plugins using a static method. We would like to be able to test this method and make eventually some changes to the filter logic or anything like that. The problem with this method is that we are calling static methods. We are actually creating classes in the middle of it. So it's very difficult for us to put this under test. Let me very quickly show you the rest of the code. We have a plugin that actually contains a name, config class. You can assume that it's a lot of complicated code you don't care about and might be reading from a file system or from the registry or whatever. The plugin repository is also a very complicated piece of code that get a list of plugins from a remote location or anything like that. And for the purposes of this video, I'm just throwing an exception just to simulate that it's impossible to code using the test. And then I have a test that create an instance of plugin service and then call count plugins. So if I run the test now, of course, let me pin this one, you can see that we throw an invalid operation exception. So it's not possible to easily assert the result of the count plugins because we throw an exception. So we are calling a method that we can't mock easily. So let's see how we can use this extract and override technique in order to break any sort of dependencies in legacy code bases. So the approach is the following. You select the piece of code that you don't care about specifically for the particular testing you're writing that you want to actually mock out, and you extract that into a method. And let's call this method getPlugins, for example. Okay? Right, so now I have a static method that returns a list of plugins. I can just return here directly. And now I isolated the getPlugins code from the actual count plugin. So the trick here is that we can remove the static and we can make this method protected virtual. So I'm making this method virtual, okay? So I am exposing this method to the aside walls, allowing subclasses to override the behavior of this method. And that's exactly what this technique is about, because we want to be able to create a class in our test that actually mock out the behavior and replace it with custom logic that we want to use in our test. Okay? So now, after I've done this, what I can do is, in the test, instead of using the plugin service, I'm going to create a specific class that inherits from it, that mocks the behavior that we just extracted. Let me call this class a plugin service stub that implements plugin service. Okay, let's implement, let's override the getPlugins method. Okay, so for now, I can just return a list of plugins, just an empty list, okay? Just for the purpose of this test. Let's use this class in the test. Now, if I run the test again, what happened is that we don't get the exception anymore because we actually mocked out the behavior of the plugin service class, and we actually get a proper assertion error that we expect to get 3 results, but instead we get 0. And the reason is because the service stub returns no plugins. So obviously this test is not correct. We need to change the stubs in a way that we actually return the list that we care about. So the ideal way of doing this is, instead of returning here an empty list, we will return a list that we will provide in the constructor of the stub. Let's say here I create a constructor, and the constructor takes a high list of plugins. Then I call it plugins. Okay. Then I create a read-only field, and then here I return this field instead of an empty list. Okay, now I have a fully customizable stub. So here in the test, I can actually provide the list of plugins that I care about in this particular test. So let me create a plugin here, and the first one is called C# 1. Then I have another one that, let's say I have other, oops, all right. Okay, so let me create other 4 of it. One is VB, one is C# 2, and one is I love C#. Okay, now if I run the test should pass because there are 3 plugins that satisfy the filter condition that we care about. Okay, so let me repeat what we actually did here. We have a class that contains a method that we want to test, but we are unable to test because the method itself is using some sort of configuration or static state that we can't actually easily mock out. So in order to do that, we extract the piece of code that we want to mock out in a method. We make this method virtual, and then in the test, we create a stub that implements the actual service and class that we want to test and override the virtual method that we made available, so that we can provide a custom list of custom behavior for this particular piece of code that is easy to test. In particular, in this case, we want to return a specific list of plugins. So this actually allows us to test any filter logic or eventually add additional filter logic without worrying about how the plugins are actually retrieved when you run the application in production. So what are the advantages of using this technique? As you can see, it's definitely reducing the coupling and increasing cohesion because it's putting the code actually load the plugins out of the count plugins method, or somehow it's a bit isolated from it. And we haven't creating any interfaces or any abstractions, so we can just do this fairly easily. We're just creating a method and made it virtual. So extremely simple to do. You can do with any classes you want, and there is no excuses to not be used. So any class, no matter how complicated it is in terms of dependencies, allows you can actually benefit from this technique. And it's really powerful. It's very pragmatic. It's a very pragmatic approach. It's especially useful for static dependencies, like this one that is actually a call to a static method. The downside, and it's why a lot of people do not like this approach, is that requires to use the virtual keyword in C# that actually expose some internal details of the class. So basically break a bit the encapsulation of the class, if you want to say that. But I honestly believe that when you are working with legacy code, one of the main priorities is actually to be able to test the code and be able to make changes easily in a very safe way. And this approach is extremely safe to do and allows you to test even more very complicated code that otherwise wouldn't be easily testable. So breaking a bit encapsulation in this case is not too much of a concern, especially if this class maybe is used inside of a module of your application that is not even exposed to the outside world. In that case, there is not really too much to worry about. And I think Roy, the author of The Art of Unit Testing, put this very well in his book. And he said that this is kind of a testing object-oriented design. It's kind of an extension of object-oriented design that allows you to test more easily some classes. Of course, this is not the only techniques available, and this can be considered as a step forward in order to make the test, the code better. So nothing stops you in the future to extract this getPlugins method out of this class and maybe create a service to inject in this class. And we will see these techniques in other videos. So don't consider this as the only step you have to do in order to test legacy code bases. It's just one technique that might be the initial step towards a better design. After I said that, I think this is a very powerful technique. You need to consider to use this in your legacy code base, and is definitely a technique that I recommend.